Baranga. Anyway, uh, um, so I watched this video. Watched this video. Wait, let's check the audio. How is the audio? How is the audio? Mic check. Mic. It's probably completely off. So the default output is the headphones, and the input is the USB. Let's check. Check it. Why is this here? So let me check StreamYard. StreamYard. Okay, it looks good. Okay, let's listen to it on the iPhone. Prepare to meet the iPhone. Uh, iPhone. There it is. Prepare to meet the iPhone. Well, there you go. Sounds good. Sounds good. Feels good. Tastes good. Saw. Very good, very good, very good, Anakin. All right. So what we're gonna do now? What we're gonna do? Well, I wanted to continue. I wanted to continue doing the calculations because we stopped halfway in the calculations. But I also wanna. I took a break and I was watching Zabine. Sabine Hustenfelder. Sometimes she's really amazing. Sometimes she's really horrible. Today she was really amazing. She said everything that I've been saying, but I've been saying it from philosophy of science, from my basic assumptions, and she is saying it. Well, I don't know what her reasons, but I guess from research. I don't know. Anyway, let's listen. It's a long video. It's 25 minutes. It would take me endless time probably to go over it. Let's begin.
According to the headlines, last year's Nobel Prize in Physics.
So the headline is The universe is not locally real, and the physics Nobel Prize winners proved it. So it's not locally real. Elegant experiments with entangled light have laid bare a profound mystery at the heart of reality. No one knows what's going on here. Why is this in Arabic? This is Scientific American. Let's listen.
Was awarded for showing that the universe is not locally real, or for spooky quantum behavior and spooky.
Let's see. Oh, wait. She's
Universe is
skipping
not
too
locally
fast
real,
between the
or for
titles.
spooky.
Nobel Prize for this is from Space and Science. Nobel Prize for quantum physicists who explained particles' spooky behavior by Rob Pichetta and Katie Hunt, CNN. This is October 22, and this video is recorded a year ago, July 8th. Today is September 2nd, I guess.
Quantum behavior and spooky action at a distance.
Quantum spooky action. Wait, we have somebody with us. Non-local. Uh, non-local. Well, that's what we're looking into. You want to join us, Mr. Guts? You have the link, do you? Do you have the link? Let me give you the link. The link. Can you react to this video on live stream if needed? What do you mean? I'm reacting right now. You can join me. Here is the link. Where's this is 2, where's 3? I'll give you the third. I'll give you today's link. Okay, copy, and here's, this is the video, so do with it as you want. I mean, you can join me, we can react together. Wait, you can't hear me yet. Okay, you have all the links. So join me if you want at your own peril. So quantum spooky action at a distance. I know the end. I know where she's going. So she's going exactly where I was hoping someone would go. I didn't want to have to do this all by myself. Da all by myself. Anyway, I didn't want to do it, so she's making it much simpler for me. So when it comes to the foundations of physics, she is essential, but she's basically the only one. It's like everybody else is unscientific. She's the only one who is being scientific. I don't know what to do. You listen, you're not gonna believe it. This is like unbelievable.
Distance.
Wait, so quantum spooky action at a distance land scientists Nobel Prize in Physics. They designed experiments that proved particles could affect each other instantaneously over vast distances. That's a violation of the speed of light. That's a violation of causality. If this subtitle is true, then we live in a universe in which effect precedes the cause. First, you have the effect, then you have the cause. That's what this says. They designed experiments that proved particles could affect each other. If you say instantaneously over vast distances, that's basically going back in time. So if that's our universe, that's not the universe I know we live in. So there you go. That's a universe I cannot understand.
Or for exploring.
So the New York Times, Nobel Prize in, wait, who was the previous one? I'll tell you. So CNN, Nobel Prize for quantum physicists who explained particles' spooky behavior. That doesn't say anything. If you're explaining spooky, that's good. So CNN is good. CNN is okay.
Quantum behavior and spooky action.
So Live Science, never heard of them. This is anti-scientific.
The distance. Or for
Okay, New York Times. Nobel Prize in Physics is awarded to 3 scientists for work exploring quantum weirdness. Okay. Elaine Aspect, John F. Clauser, and Anton Zeilinger were recognized for their experiments in an area that has broad implications for secure information transfer and quantum computing. I doubt it. I doubt it. I don't know where they're getting this from. Why would it be more secure? Why would we have secure? I don't think there's any of that. And quantum computing. I don't think quantum computing exists. I don't think there is quantum computing. Quantum computing is exploiting the weirdness, but the weirdness doesn't exist, so there's nothing to exploit. So there is no quantum computing, as far as I'm concerned. Quantum computing is a violation of science, the scientific assumption that the universe is mechanical.
exploring quantum weirdness.
One of the laws, a mechanical universe cannot do anything instantaneously. Instantaneous is not a mechanical universe. You cannot have anything, any cause and effect be instantaneous. Everything must have a speed limit. And the speed limit we've witnessed in this universe is the speed of light. It's about 3 times 10 to the 8 meters per second. That's it.
What's that supposed to mean? Is the universe really not locally real, or not really local, or not really real?
That's good. I mean, so usually I don't like it when she makes fun of physics, but sometimes it's appropriate. This is an appropriate time to make fun of physics and physicists.
That's what we'll talk about today.
That's a fake smile. Go. So science without, but the without is crossed out, the gobbledygook. Sometimes she is gobbledygook, but today she's mostly very clear.
My grand plan for this video is that we'll first
Very long video. She usually doesn't do 25 minutes.
look at what locality means, then we'll talk about quantum mechanics, and then we'll combine both.
Right, so good.
Let's start with locality. You all know what locality means. It means if you want to go to New York City, you don't just disappear from Heathrow and reappear at JFK. You must get on a plane, fly in a seat through the sky, and then drag yourself into the immigration queue at US Customs. There's no instantaneous going anywhere. It's not just
She always makes fun of America. I don't know. She has this obsession to make fun of America. She doesn't like immigration. I don't think anyone likes immigration, so whatever. Okay, so that's her definition of locality. Locality means, by example, you cannot disappear from one place and show up somewhere else. How that means locality? I don't know why that means locality. I don't know. Why is that the definition of locality? I don't know. Why is that locality? I'm trying to think how the locality, the way I understood it, it just means that you cannot violate the speed of light. That there is I guess that's what it means. There is that the universe is mechanical, and in order to have cause and effect, it cannot be instantaneous. Nothing can be instantaneous. And I guess if you could instantaneously teleport, that would be therefore a violation of locality. So her example fits my intuition of locality. Locality just means a mechanical universe. Why? But why does the word locality means? I guess because you're supposed to influence. You cannot influence anything beyond what is right next to you. You cannot have spooky action at a distance. So you cannot. So why does the apple fall from the tree? It cannot be some spooky action at a distance. There has to be. So the earth is influencing something right next to it, which is influencing something right next to it. And this propagates to the apple. And the apple, therefore, in my explanation, so there is this fluid that the earth is vacuuming into it, and this vacuuming causes the fluid to flow into the earth, and the flow goes through the apple, and the apple gets sucked into the earth. But the earth is not influencing the apple directly. The earth is influencing only the ether particles with which it is interacting directly. So my explanation of gravity is very mechanical, unlike basically anyone else. I don't think anyone else, maybe Inductica has this. He doesn't go into the details. But that's my intuition of gravity, which is very mechanical. So it's very local. So everything is local. So the sun, obviously, how does the light from the sun reach me? So the sun causes electrons to vibrate. The sun is a bunch of electrons vibrating, going up and down the energy levels of the hydrogen atoms, or maybe helium or something, who knows. So the atoms, the electrons go up and down, I think. And every time they go down, they smack on the bottom level. and they shake the ether. They cause a vibration in the ether, which is a photon. And this photon is the waving of the ether, and this waving of the ether propagates very, very slowly at the speed of light, which is very slow. It's local. It's a local propagation, and there's photons going in every which way from the sun, but it's local. So that is locality. Locality is that you can only influence whatever cause and effect take place in our universe. It is local. The cause is local, and the effect, it must be a chain reaction. It can't, there's no skipping over. Didn't he say he wants to join us? Where is he? Can you react to this video on live stream if needed? Well, this is the video. I'm doing that right now. Anyway. Oh, bye. How many people? Oh, there's 2 people. So 1 person is watching. Well, at least 1 person is watching. Ti-da-da. So, okay. So we're beginning to understand. Let me just check the audio. Ti-da-da. So, okay. So we're beginning to understand. Let me just check the audio. The audio is fine. The audio is just fine. All right. So this is a very deep definition of local. I've heard this before, and every time I hear the word local, I forget and I have to reinvent it for some reason. But that is local. Local just means the universe is mechanical. So if you believe the universe is local, then the universe is mechanical. And that's the only universe I can understand. I cannot understand a universe that is not mechanical. That's just, a limitation. That's a me problem. So if you can understand a non-local and non-mechanical universe, well, good for you, You are what I call a liar, obviously. Because if I cannot understand something and you claim you can, then obviously you're a liar. You're a hypocrite. You are pretending. So you cannot understand it. All right. So you might say, well, I don't understand it, but it's true. Well, you have no evidence for that. Well, of course we do. We have evidence. No, you don't. No, you don't. These are nice stories that people tell each other, but there's no evidence. There is no evidence. I claim, I make a proclamation. There is no evidence for non-locality. Does not exist. Bell Schmel. I don't know what Bell said. She's going to go through what Bell said. She's going to say that Bell made a mistake. Bell overlooked. Bell didn't understand. And the Nobel laureates that got their Nobel for proving Bell right, they got their laureates for proving Bell right. They say, well, yeah, but Bell didn't understand that he got it wrong. But it doesn't matter. So that's the spoiler alert. I'm not sure I'm going to be able to go through literally everything she says because I was watching her and some stuff went over my face. 1 second. What is this? Whoa, that's interesting. I don't care. That's useless. So I'm waiting for a message. And any emails? That's fine. Everything's fine. I missed a phone call. Did they leave a message? No message. I don't care. All right, let's continue. But this one we don't need. We don't need this. Okay. Let us continue.
Trouble. It's generally any interaction. You can only immigration queue at US Customs. There's no instantaneous going anywhere. It's not just travel, it's generally any interaction. You
I don't know if she understands the definition of locality the way I understand it, because she would have explained it the way I explained it. That locality means you can only influence something that is right next to you. You cannot influence something that is not immediately next to you. If it's not local, you cannot influence it. She's not going through this very critical step. She's skipping to a weird example of disappearing from London and appearing in Heathrow, wherever that is. Where is Heathrow? Where is Heathrow? Where is Heathrow? Heathrow. No, Heathrow Airport. Heathrow. Welcome to Heathrow Airport, UK. It's in UK. So what is she talking about? I don't get it. So you leave Heathrow? Didn't she say you get to Heathrow?
start with locality. You all know what locality means. It means if you want
You all know what locality means? We do?
to go to New York City, you don't just disappear from Heathrow and
Yeah, okay. Disappear from Heathrow in UK,
reappear at JFK.
JFK. Okay. But that's not, I don't know, with the map. Anyway.
You must get on a plane, fly in a seat through the sky, and then drag yourself.
I wouldn't say that's locality. I don't know how that is locality. Locality is trying to cause an effect. Locality has to do with cause and effect, that the effect must be local to the cause. A cause can only affect a local effect. That's the definition of locality. I don't know. This example is weird. That's not it's not an example I would use for locality.
Into the immigration queue at US Customs. There's no instantaneous going anywhere.
It's nothing to do. I guess instantaneous. It can. That also comes out of locality. I would separate these notions. An instantaneous universe could exist if the particles of the ether were massless. Then, but can you have massless particles? I mean, the actual ether is particles. Those are not waves. Those are actual particles. That's the way I see them. It's difficult to know. Anyway, so an instantaneous cause and effect, you could say, well, I can influence locally, but the propagation of the influence could be instantaneous, could be super, super, super fast, that it's instantaneous. That's a different notion than local. But maybe everything falls under local universe. Maybe both, that the cause needs to only influence a local effect, and this progression of cause and effect, this chain reaction cannot be instantaneous. These are all the definition under the same definition of local.
It's not just travel, it's generally any interaction. You can only act on things next to you.
There it is. Okay, very good. That is local. So I don't know why she started from a weird example.
And it's not just you. No, really, I swear. Anything can only interact with things right next to it. This is what we.
Yeah, that's an incredible statement. It's such a simple statement, but most people think that the Earth is holding on to the moon with no strings attached, because they don't see the strings, so there is no strings. But there is a string. not a literal string. There is a proverbial string, and that is that the Earth is annihilating the ether and is causing a collapse of the ether. And there is an ether pressure in the universe. That's dark energy. So there's always a flow into massive bodies. So there is flow into Earth. It goes through the moon, and that's what's dragging the moon into the Earth. But the Earth is only impacting the ether that is right next to it. So right now, the ether is being annihilated, but for some reason, there's no way I can detect it. The only detection is, what is the detection? Like, there's no energy released. How could it just be annihilated? It just annihilates. It just poof, disappears. It has a mass. It can't be massless. So, I mean, that's why the speed of light is not instantaneous. It's really weird.
We mean by locality. Non-locality would basically be a portal. Something goes in and instantaneously appears elsewhere.
Well, I wouldn't say something goes in. I would say that I could affect something from the distance, like a Jedi. But even a Jedi could work. A Jedi could work theoretically if the Jedi doesn't violate the speed of light. If the Jedi worked within known laws, the known laws of physics. I don't know if in the original Star Wars the Jedi was able to influence things from the distance. Was he? Yeah, no. Did in Star Wars? I don't think in Star Wars, in the original Star Wars, the only power that the Jedi had was the mind trick, which is a copy of the voice. The original Star Wars was basically a copy of Dune. So Tatooine was a desert planet, and the Jedi used mind tricks, which is the voice from Dune, which influences the weakly minded. That was the only power that Obi-Wan had. What other power did Obi-Wan or Darth Vader have? So Darth Vader was able to choke, to strangle that that soldier, that general, whatever. But you could say that that's just a mind trick. So people misunderstood it. They thought that he's actually able to manipulate something from a distance, but he was not. It was a mind trick. But the general was a weak mind. Anyway, but fine, so it's a portal. Portal is a violation of locality.
Now, if you could travel non-locally, that might allow you to go faster than light, but it doesn't.
So if you could interact,
Could travel non-locally, goes in and instantaneously appears elsewhere. Now, if you could travel non-locally, that might allow you to go faster than light, but it doesn't necessarily. Non-locally, that might allow you to go faster than light. Basically be a portal. Something goes in and instantaneously appears elsewhere. Now, if you could travel non-locally, that might allow you to go faster than light.
I don't understand. I mean, that is the definition of going faster than light. What do you mean it might allow you? If you go through a portal, then you have violated the speed of light. Obviously, you violated any speed. Once you skipped, you disappeared here and you appeared there, that is a violation of the speed of light. I don't know why she says it might.
But it doesn't necessarily have to. Alice could go to Tokyo faster than light without taking a portal. Bob could go through a lake.
That's not what she said. She said if you take a portal, that might violate the speed of light. That's not true. It definitely violates the speed of light, but the reverse is not true. If you violate the speed of light, it's not necessarily through a portal, right? So I don't know. I think she got this wrong. She says here non-local travel, which is what? I don't know what she means by local at this point. It's either a portal or it violates the speed of light. So she says, did not find any threats. All right, no threats. Good. Anyway, yeah. So she says non-local and faster than light are not the same thing. That's good. Didn't she say the opposite before? Yeah, but I would separate it. The speed of light and non-local are different because you could influence something locally that would propagate faster than the speed of light. Theoretically, it could happen. It's just that we never noticed it because all we know is the ether, whether we call it the ether or not. But that's all we know. All we know is nature, and in nature, we've never seen any propagation of energy faster than light. Could we see it? How would we test for it? How would we know that it happens? How would we know that it happens? I guess if we fired a light beam at the moon and it came back under the time that it should, because we know the distance to the moon, but then we would have to assume that the moon has moved closer. Why would we assume that the speed of light was violated? But theoretically, it could happen. I don't know how we would know that it happened.
Same portal that brings him to New York even later than Air France and leaves his bag in Paris again.
Wait, what? She's so confusing.
Taking a portal, luckily, that might allow you to go faster than light, but it doesn't necessarily have to. Alice could go to Tokyo faster than light without taking a portal. Bob could go through a lame portal that brings him to New York even later than Air France.
Okay, so you could go through a portal slower than even crawling. Could be a very slow portal. You walk in this part of you walk into Heathrow and you appear in JFK a year later, so that even if you swam across, it would have been faster. Okay.
And leaves his bag in Paris again. So not
That was a joke that they always forget your luggage.
on locality and
It actually happened to me. I lost my luggage in the last trip.
faster than light.
But after like a week, I got it or something. I don't remember anymore.
Travel are two separate things, but the two are related in that Expedia isn't offering either.
Okay, so she's making a lot of jokes, and it's a little bit difficult to follow her.
Maybe more importantly, though not unrelatedly, neither of them is allowed in Einstein's theories of space and time. Yes, that guy.
Einstein, what? His theory of time?
Neither of them is allowed in Einstein's theories of space and time.
Theories of space and time. Theories. So, why relativity? Relativity is the theory of gravity. I don't think it has anything to do. I guess he discovered that gravity slows down time as well, which is an obvious outcome of the ether, but that's fine. So his theory. So what?
That Expedia isn't offering either. Maybe more importantly, though not unrelatedly, neither of them is allowed in Einstein's theories of space and time.
Neither is allowed. What do you mean neither is allowed? I don't remember reading that Einstein doesn't allow exceeding the speed of light. I don't remember that. He just said the speed of light is a constant for all moving observers. That's all he said. So this is going to end up being a review of this video. So let me change the name of today's video. So if people want to join us, so this 83. Okay, so this is a response. It's not a response. It's a review. It's research. Is it research? Am I researching? I'm just watching. So just call it watching. Watching. Okay. Okay, so I changed the name.
Yes, that guy again. We can make a little drawing to see what this means. This is a space-time diagram. The horizontal axis is one dimension of space.
So I usually don't like space-time diagrams. They were invented, I think, by Minkowski. I don't think Einstein liked them. Einstein said since mathematicians invaded relativity, I no longer understand it. I don't think Einstein liked space-time diagrams. Anyway, but they have a little bit of a convenience, maybe a lot. If you really begin to understand them and be able to play with them, they could be very powerful tools. I guess they are very powerful tools because people. I mean, it is possible to shift the two coordinate systems and get amazing predictions really quickly, which I don't deny. So in my ether theory, the ether, so you can calculate whatever you want relative to the ether, or your motion, or you can calculate your own motion, you as the observer, and the observed their motion relative to the ether, and you can calculate each one's clock and length and relativistic mass. You can do all these calculations in relative to the so-called absolute frame or preferred frame of reference, that is the ether. And then you can, like two vectors, add them and get the resultant vector, and that's Einstein's relativity. Einstein just skips the middle person, that is the ether. He says there is no ether, but let's calculate relativity of the observer and the observed. That's fine, you can do that, but you can also calculate it relative to the ether. It's just there's no difference. The difference is reality. So either there is an ether or there isn't. So we're in the middle of proposing a new ether experiment, but we're just taking a break because I watched this. But we should get back to our ether experiment after we finish this, or at least I would just want to get to where she says, but she says it towards the end. She says really unbelievable stuff that if I've known this from before, it would have saved me a lot of time.
Space, say left or right. The vertical axis is time. If you don't move but sit still, that's described by a vertical line in this diagram. If you move at a constant velocity, that makes a line at a fixed angle. By convention, a 45-degree angle is the speed of light. According to Einstein, nothing can go faster than light.
No, no, that's not. It's not according to Einstein. Why do you say that? I don't know where she gets it from. I'm trying to think. Where did he say it? I don't think he said it. Where? What did he prove it? Did he say it? Did he assume it? None of the above. I don't think he. I don't think he had a position about this. I don't remember. I don't remember him mentioning it. Nothing can move. They keep saying it. Nothing can move faster than light. I don't think Einstein said anything about that. I mean, we've never noticed anything moving faster than light. That's it. So you don't need to implicate Einstein.
This means if an event happens here, then anything that can be influenced by this event must lie within a region that's bounded by 45-degree lines emerging from the event.
Obviously, Einstein didn't show space-time diagrams in his 1905 paper. Minkowski didn't invent space-time diagrams at that time yet.
This boundary is called the future light cone, and the region that can be influenced from the event is that inside the future light cone. Likewise, there's a region which contains everything that can influence the event, which is the inside of the past light cone. If something could go faster than the speed of light, it could enter your light cone like this. And if non-locality was possible, it wouldn't have to respect those light cones either.
That's very good. That's non-locality. That's good.
Could just jump into your light cone. For the rest of this video, we'll assume that faster than light travel can't happen and just look at non-locality. If you'd rather hear me talk about faster than light travel, I have another video on that. Our experience suggests that reality is local, in that these jumps in space-time don't happen. There's no action at a distance, no portals. However,
She didn't say spooky action at a distance.
our descriptions of reality are not always local. Suppose I take two sheets of paper and write the number +1 on one and -1 on the other.
Okay, so this is a thought experiment. So she says that sometimes. So where is she going with this now? So she's going to try and show non-locality, that something that looks like it's non-local, or that of course it's local, but it looks non-local. It looks like, well, let's see what she says. So she took two pieces of paper. She drew +1 and -1 on each one. All right.
Put them in two identical envelopes. Then I send one to Alice in Tokyo and one to Bob in New York, who is still waiting for Air France to deliver his bag. Alice and Bob both know what I did, but not what's in their envelope.
Okay, so Alice and Bob know what she did, that she took two pieces of paper, wrote +1 on one of them, -1 on the other one, put them in envelopes, and sent them to each one. So they each know the complete story of both envelopes. Let's even imagine they can look at each other. Let's imagine they're giants. They saw the whole process. They don't even need to be in separate. They could be in the same room. They could have seen the whole process. And let's say they were together in the same room when the two envelopes were written, closed, and handed to each of them. But they don't know which letter or which number, which digit, which number is in each envelope. They were handed these envelopes, and then they went to these different places in the universe.
Either the +1 went to Bob and the -1 to Alice, or the other way around. It's a 50-50 chance. But the moment...
As far as they know, it's 50-50, okay. But we know that the reality is it's either one.
Alice opens her envelope and finds +1, she knows that somewhere in New York there's an envelope.
She knows instantaneously, which seems to be like a violation of locality. She has instant knowledge of something that is distant. It's almost like as if she's influencing Bob and his envelope. Poof! Her opening her envelope and seeing it's +1 is influencing his envelope that is now -1. Wow, magic. Magic. Can you believe it? It's magic. This universe is magical.
With the number.
This episode is absolutely I can't take my eyes off this episode. This episode is as delicious as any episode has ever been in my entire life. I'm drinking every word Sabine has to say in this episode it's unbelievable. It's the same woman who makes episodes about global warming. She also believes in global warming, which is incredible. Such a smart person who understands what apparently almost no other physicist understands, yet she believes in nonsense. Anyway, so spooky action at this distance.
-1. You probably didn't find this particularly remarkable.
Right. This is the most ridiculously obvious thing in the universe.
Well, what did you expect clicking on a video about locality? Only so much I can do to spice it up.
That's so funny. It's like when other physicists talk about locality, it's weird. This universe is a weird. It's a weird universe.
Remarkable or not, this simple example will be useful later. Thing is, these numbers in these envelopes are correlated. You don't know what either is.
So when she says correlated, when you listen to other physicists, Sean Carroll comes to mind, they say entanglement is not correlation. It's not correlate. They keep repeating it. I was just listening to them the other day. That entanglement is not correlation. It's something else. But she says no, it's correlation. So I think she knows the other what the other guys say, and she doesn't like it. Wait a minute, I have a message. Oh my god, I'm not gonna take it. Not taking it. Let me get rid of it. Oh my god. Leave me alone. Leave me alone. 1 second. One second. Okay, let's wait for a response. Let's listen to Sabine.
But if you know one, the other one is not random anymore. And this correlation can stretch over a distance. If you learn what one number in this correlated pair is, you learn something about the other number elsewhere instantaneously.
Yeah, it's instantaneous. So you might think, 1 second, let me check. Oh, 90% battery is never good. So you might think, oh, the instant communication. The instant communication. The universe is so weird. We live in a weird universe. We live in a weird universe. The universe is weird. It violates. The universe is even weirder than we thought that it could ever be. It's so weird. It's such a weird universe. And she says, no, the universe is actually rather a boring place. And if you find it too boring, then you should look for another universe. Zabine, in this episode, saves the day. It's worth it to have suffered through all of Zabine just for today. That she dissolves or resolves all the quantum nonsense in one episode. Well, what's going on? I'm still waiting for an answer.
You could call that a kind of non locality, but it's not an
It's a right. It's a correlation, non-locality. Very good. No action at a distance. Exactly.
action at a distance. The only action that happens is an update of knowledge about something elsewhere. The action itself is completely local. It happens in.
Okay, let's see the message. Um, 1 second. 1 second. One second. Okay.
Bob's brain, or Alice's, unless maybe they've become so bored by my number games there isn't anything left of their brains. So the
She's good. That's good because quantum mechanics, Sabine is making quantum mechanics simple. She is saving the day. After everyone ruined the universe, she's bringing order to the universe. Hooray, Sabine. So I first knew Sabine when I saw her video about Lost in Math. That's when she came to the scene. I think I saw her video when she first came to the scene to YouTube, and I was blown away. She was the first one that I've ever heard who said that physicists behave like a cult. She told us about how her grandmother used to warn her that people behave people are dumb in large groups. That is what happens to even physicists. The smartest people in the universe are susceptible to this madness. So when she said that, that was just unbelievable to me. Because I had nothing, I don't think at that time I had anything to say about physicists. I felt something was wrong with physicists, but I had nothing, I never had any interaction with physicists. I didn't know anything about it. I didn't have a position, and she said it, and it made a lot of sense. So every once in a while, she makes this unbelievably powerful video. This video is unbelievably powerful.
lesson of the first part is there are two types of non-locality. The one is a physical non-locality, an action at a distance, which is like something going through a portal. The other is a non-local correlation that allows us to
Okay. So there's physical non-locality, which is a fairy tale, and there is knowledge non-locality, which is boring.
acquire knowledge about what happens elsewhere.
When I find out which letter I have, I know which letter Bob has. When Alice knows what letter she received, instantaneously she knows what letter Bob received, which is boring. And that is the only non-locality in this universe.
But in this case, the only physical changes are local. Let's then talk about quantum mechanics. In quantum mechanics, everything is described by
Okay, so until now she was just defining terms.
a wave function, usually denoted with the Greek letter psi. The wave function is a device that we use to calculate the probability of getting a particular measurement outcome.
I need to figure out this wave function. I still don't, I don't know anything about it.
But it doesn't predict the outcome with certainty. We say that quantum mechanics is not deterministic. Imagine, for example, you have a single quantum of light.
That I understand that. I mean, the wave function is just a summary of the data. And the data is that we don't know when an electron, when we send an electron through the double slit, through the two slits, we don't know what it's going to do, but we know with a certain probability where it's going to be. If we look at that place, what is the probability that it's going to be there? Because we've done the experiment many times, so we know statistically where it's likely to be, where it's more likely to be, and where it's less likely to be. It's really very simple. Right? So if I show a child, literally, I would say a 3-year-old, 4-year-old, if I would show them the double slit experiment with the results, and I would then ask them, okay, I'm going to fire an electron. Where do you think it's going to land? They would say, I don't know. I would ask them, what is the probability, or how likely is it that it's going to land where it's very dark? Let's say where it's dark, that's where the electrons hit. Every time there's a hit, no, let's say it's very light. Where it hits, there's a light spot. So we see a dot and a dot, all these dots coming up slowly, more and more and more dots, until we see a wave pattern. Okay, and then I asked the little baby, okay, the next electron I'm going to fire, is it going to land next to where a bunch of other white dots, where there is a high density of white dots? What's the probability that it's going to land there compared to where it's very dark, that almost no dots have shown up? So where is it more likely? Where is the next electron that I found? Where is it more likely to hit? Where it's dark, where there is more density of spots, or where there is a lower density of spots? And the little child would say, of course, where there is a high density of spots. They seem to conglomerate, they seem to coalesce, they seem to want to hit those spots where there's high density. They go to these places. That's the nature of the animal. Oh, that's it. So the little baby has the Schrodinger equation in their brain. It's built into their brain. It's very simple. There's nothing complicated about it. That's just the data. We saw the data. Monkey see, monkey do. Even a monkey would probably, after seeing the double slit experiment once, if I would have it gamble, we can teach monkeys to gamble. So a monkey would bet correctly to get food. That is all that the Schrodinger equation is. That's all it could be. That is the wave function, whatever that means. But that's all it is. That's all it is. It's based on data. As far as I understand, that's all it is. All right, so where were we?
Is not deterministic. Imagine, for example, you have a...
Right. So when I asked the chimp to guess the next electron, the chimp doesn't believe in it. It's not that the chimp has to assume it's a deterministic universe, that it's not probabilistic. It is deterministic in a probabilistic way. It's not predictable. The chimp doesn't have an opinion whether the universe is probabilistic or deterministic, or whether it's deterministic or not. It could be deterministic and probabilistic, but then there is hidden variables, which is fine. The chimp doesn't care about these considerations. The chimp doesn't have an opinion, but the chimp, by placing a bet, tells us that it believes the universe is mechanical and there are hidden variables. So the universe is 100% predictable, but there's hidden variables that the chimp is not aware of. All that the chimp knows is the probability, which is fine. So the chimp gambles correctly on the high density regions of the double slit experiment. So the universe is not probabilistic. Our current knowledge tomorrow morning we might discover a way to predict the double slit experiment through the hidden variables. What could be is that the hidden variables is the ether particles themselves. Right? Don't forget the ether particles are there and we cannot see them. I don't think there is any. I'm trying to think of any way that we can detect them. I don't know. At this point, I honestly I don't have a position about the ether particles. But if the ether theory is correct, then that is the hidden variables, and there's no way we can get the hidden variable. We cannot get to these hidden variables, but they're there. So the universe to us looks like it's probabilistic, but it's not. It's perfectly mechanical. It follows mechanical laws, very, very mechanical laws. It could be literally little weights with springs. It could be. Who knows? I don't know. That a photon is just a wave in that ether. That's all it is. We live literally in a clockwork universe. So what? I wonder if Zabine, if she would watch this video, if she would appreciate my analysis. She would find it abhorrent that I'm talking about the ether. Even for her, it would be too much. But she believes in hidden variables. So she would actually enjoy it. But I don't know how much, because she is still mainstream. I don't know if she has the will, she has enough will to stand up to the powers. I don't know. Maybe she is hated in her community. They hate her. She keeps telling politicians to not invest in bigger particle accelerators. They hate her for it. So I wouldn't be surprised that she has death threats that she hasn't revealed from physicists. I would not be surprised. Nevertheless, let's listen.
We say that quantum mechanics is not deterministic. Imagine for
I wouldn't say that we say that quantum mechanics is not deterministic. It's just that there is hidden variables, that's all. The envelopes are sent. We don't have access to how the envelopes were sent. But, we're following envelopes. We're opening and reading envelopes, and we know things about other envelopes.
For example, you have a single quantum of light, a photon, and you send it through a...
Why would you show a photon as a particle? I would show it as a wave, as a wavelet. Anyway, so it either goes through or doesn't go through.
Semi-transparent plate.
A semi-transparent mirror. Okay.
If you still have the space-time diagram in your head, please take it out and put it aside for now. This illustration just shows 2 dimensions of space. Think tabletop. The photon has a 50% probability of going through the plate and a 50% probability of being reflected. So long as we don't observe the photon, its wave function changes locally from one place to the next by spreading into these 2 directions.
Okay, so we don't know. But it doesn't mean that physically it's at both places at the same time, which means she's taking a position on Schrodinger's cat. She's saying, of course, the cat is either dead or alive. We just don't know, but the cat is either dead or alive.
But once we make a measurement, we know where the photon went.
Exactly. It didn't go to both places. We just didn't know.
Then the probability jumps to 100% on the one side where you've measured it and drops to 0%.
So we instantaneously know about something somewhere else, right? Our eye we're over here, and immediately we know something about this location. So that's instant knowledge. Ooh, the universe is so weird.
On the other side, this is like when Alice opens her envelope and sees the number +1. Now she knows that the probability that Bob has +1 is 0. And
Exactly.
like Alice adjusts her probability for Bob when she opens the envelope, once we measure the photon on one side, we have to update the wave function to reflect this change in probability on the other side. Why? Because otherwise it doesn't agree with our observations. This update is also sometimes referred to as the collapse or reduction of the wave function.
So this is incredible. She says the collapse of the wave function is just the update of our knowledge. There's nothing peculiar that happened in the universe. Nothing happened to the universe. The universe didn't change. Once we realize where the photon really is, nothing changed in the universe except for our knowledge of the universe, that's very nice, but nothing happened to the universe besides our knowledge. So our knowledge is the wave function, we're just updating it, and that's called the collapse. That is the collapse. Otherwise nothing is collapsing. The collapse is just when I show the chimp, then okay, the chimp made the bet. So as long as the bet was up in the air, the electron could have gone anywhere. So the wave function was spread. That's literally all it says. The chimp is the machine called the wave function, the Schrodinger wave equation. And then we fired the photon, and the photon landed somewhere, and the chimp saw it. Instantaneously, the chimp slash the wave function collapsed. The chimp's knowledge of where the electron would land collapsed to a specific place. That's the definition of the collapse of the wave equation. How everyone kept getting this wrong and still keeps getting it wrong, she's going to discuss it. This is a psychotic. This is a psychological. This is a psychosocial phenomenon that needs to be studied.
And it's not.
And it's a phenomenon that I'm familiar with from the field of that I'm coming from, the brain research. It's the same issue in brain research. People want to believe in nonsense upon nonsense instead of just going with simple interpretation of the mechanics.
Non-local. You make a measurement in one place and the wave function changes elsewhere. So quantum mechanics is non-local.
Quantum mechanics is non-local in respect that before you notice where the electron actually landed, the wave function was completely spread over the entire universe. You didn't know where the electron was going to land. In your prediction, in your universe, the electron could have gone anywhere. And then when you saw the electron, when the chimp saw the electron hitting somewhere, then the universe in the mind of the chimp was updated instantaneously. Instantaneously, the chimp learned that the electron is not anywhere in the entire universe, but rather it is at one spot in the universe and nowhere else in the universe. This is instant knowledge. This is a violation of the speed of light. But it's not. It's nonsense. It's non-local update of knowledge. Interesting that she calls it collapse/reduction. I never heard the term reduction.
In some sense. The question is, in which sense? As we saw previously, just because you gain knowledge about something that happened elsewhere doesn't mean there was a number.
She takes her time to go through this again and again, but no one in the world, I've never heard anyone in the world agree with her. This is absolutely unbelievable. And she talks about it as if This is like standard. And she is going to say exactly what I just said. She's going to say, I'm not alone. There's other people who say this, and it's actually the very guys that we're discussing in this episode, the guys that received the Nobel laureate. And here is a quote. And they're going to say literally that Bell didn't understand it. So Bell thought that he's proving Einstein wrong, but actually he didn't. He proved Einstein right. Ta-da! Let's continue.
Action. Maybe the wave function just describes knowledge rather than.
Why does she say maybe? I don't know. I mean, I don't understand. This one she says maybe. What do you mean? Because she says, well, maybe the universe is weird. But why would you say that? That would be a violation of science. Then what is the definition of science?
Than being real itself.
If the definition of science is that the universe can be weird, then why are we working so hard to understand the universe? Just say, oh, the universe is weird, done. What's the point of doing any analysis?
Maybe the photon really went one way or the other.
Why are you saying maybe? Why are you saying maybe? I don't understand this. I don't understand why she says maybe. She's like, I don't understand why she's saying it, because this entire episode is dedicated to making fun of everyone who disagrees with her, and she repeats it. But then she says maybe. Why maybe? How could the same object go in two ways, and then when we look, it's only in one place? How? If when we look it's in one place, so how could it have been somewhere like in two places at once? When we always look, we always find one. You gotta look. If when you look, you sometimes find two, or sometimes you find none, I don't know. We can discuss that. But if you always find one, if you fire one and find one, which is the way Feynman explained the electron double slit experiment, then there's no question. And if you ever fire one and discover two, that's a violation of conservation, of all different conservation laws. So if the universe is not conserving its laws, then the universe is lawless. That's not the universe I'm familiar with. This universe is extremely conservative when it comes to its conservation laws. There's never a violation. We've never witnessed a violation of conservation laws, except for with Heisenberg uncertainty, I guess. You can violate conservation laws, like I guess, because it's a wave described by a Fourier series. Oh my God, shut up. So, can we actually violate conservation laws? So the universe doesn't violate conservation laws. It's only within our knowledge. The universe is mechanical. The universe is 100% mechanical. It's based on ether. This universe is a universe of ether. Ether is this field, this quantum field on which everything exists. It's one field in which everything we know in this universe exists in this one field, and it's completely mechanical. It's very, very simple, very mechanical, 100% mechanical. It's like somebody built it, and we are machines in this very mechanical ether pool. That's all we are. That's it. Everything we're trying to understand is the waves that seem to wave in this pool of particles. So there's a pool of particles, and in this pool there's waves. Not surface waves. There are no surface waves. There's no surface. The pool is filled to the brim. It's completely full. But there is three-dimensional waves. Okay, so there's these three-dimensional waves, but these are completely mechanical. The fact that what? So what is the Heisenberg uncertainty? Well, that's the uncertainty in our ability to predict. I'm assuming, I don't know what else. And it's because it's waves. These waves cannot have, right? A wave cannot have an absolute location, as far as we know. In our knowledge, a wave, in order for it to be a wavelet, it needs to be, in order for it to be a wavelet, it needs to be what? It needs to be a Fourier series. So it needs to have, the energy needs to be spread out or something. I don't know. I don't know Heisenberg enough.
You just didn't know it, and the measurement revealed its real state. Being a wave function isn't easy. Not only do people reduce and collapse you, they also then argue that it doesn't matter because you aren't real. The quantum mechanical version of the envelope example goes like this. Imagine you have a particle with spin 0 that decays into two particles that can each either have spin value plus or minus 1. One flies to the left, the other one to the right.
Oh, she's not showing that now one is spinning up and the other is spinning down, or I mean they have to have opposite spins, which is fine because there's conservation of spin, conservation of angular momentum. That's fine.
Right. The total spin is conserved in the big.
So she's gonna blow. This is where she completely blew my mind away, because this is the example that everyone uses for entanglement, how measuring one influences the other.
Okay, so you know that either the particle going left has spin value plus 1 and the one going right has minus 1, or the other way around. But you don't know which has which spin. These two particles are.
Where it comes to spin, I had to give up because I don't understand spin. So when people use spin to show that they use spin to show entanglement, how measuring one influences the other, at that point I say, okay, I don't know what spin is, so let me go. You cannot conclude, right, based on the assumptions. We have a bunch of assumptions that, right, all these assumptions are based on intuition. Everything we know about the universe is from intuition. So you're telling me from this intuition, you're going to conclude a non-intuitive conclusion, namely that the universe, that there's non-locality. So after we assumed locality, we're assuming a mechanical universe, but from this assumption, you're going to show me that you're violating locality. Well, the only way you're going to do that is because you were telling me something about spin, which contradicts locality. So your definition of spin is already a violation of locality. For me, that's a slippery slope. So once you introduce spin as a violation of locality, at this point, I have to stop you and tell you, okay, you can stop right there. I'm not going to continue following the way you're talking, because it's a violation of locality. The way you explain spin, I don't understand it. So how do they explain what is spin? that the electron is not really spinning. So it's not really spinning, but it is really spinning. Okay, at that point I say, okay, let's hold off on any conclusions that we derive from spin. When you start telling me that it is spinning, but really it's not spinning, okay, we need to stop right there, because the universe needs to be mechanical. If you're going to tell me that the universe, that spin is not mechanical, then I cannot talk about it. I don't know what it is. So we need to come up with a model, with a mechanical model of what spin is. So you need to show me spin. You need to show me a simulation of spin that fits the data. Let's see. So, okay, we're fine. So if you don't show me, okay, we're fine. So if you're not going to show me a mechanical simulation of spin or mechanical contraption that imitates spin and reproduces every experiment that involves spin, then I'm going to tell you we cannot continue this conversation. You need to show me a mechanical explanation, a mechanical simulation of spin. Until such a time, this discussion has to be halted. There's nothing I can say. Of course you're going to reach conclusions that reality is not real, that reality is not local, that locality is not real, whatever. You can say whatever you want. In a non-mechanical universe, anything goes. And that's not a universe I'm interested in to have any part of. I will not have a part in that universe. That is not an interesting universe to me. It's not science. To me, that's not science. Science, we peel one layer of the onion at a time. So right now, we need to peel the layer of what is spin. You need to show me a mechanical spin. Once you show, it's like in the old days, they couldn't figure out the motion of the planets. It drove them insane. They burned people at the stake. They lost their minds. But in time, they came up with a mechanical explanation, and so on and so on. And with atoms, we're figuring it out. Slowly, we're coming up with mechanical models to explain more and more of the quantum universe, and it's becoming more and more mechanical. So right now, not everything is mechanical. Okay, so whatever is not mechanical, we cannot conclude, from that, the universe is not mechanical. No. No. This happened before. You gotta take it easy. You can't panic every time. You don't have an instant explanation for a phenomenon. You lose your mind and it must be God. We must be God. No, you cannot go to God. And for me, you going to, it's a weird universe. Everyone who says it's a weird universe immediately says, it's God. Oh, it's God. Oh, evidence for God. Oh, evidence for God. Oh, evidence for God. Oh, evidence for God. That's all they needed to hear. That's all they needed to hear for evidence for God. So I don't accept it. We've been down this road. If you know the history of science, you know we've been down this road many times. This is the God of the gaps. Let it go. Relax. Take it easy. Sit down. Get back to work. Figure it out. Come back when you have a mechanical explanation of spin. Until such time, don't talk about it. You can talk about it, but if you conclude, and therefore the universe is not real. No, you don't have a mechanical explanation for spin. This is just like all those other times. You didn't have a mechanical explanation for how life began. You didn't have a mechanical, so you believed in ghosts and in gods and in goblins and in witches and witchcraft. You believed in anything and everything. Let it go. You're going down a dark path. You will destroy the universe. Stop. This is a very destructive path. This is a very dangerous path. You have to stop. Oh, a message, a very important message. Oh my God. Sunday? So until Sunday? What? Oh my God. This is really terrible. I don't know what to do. That's not good news. When a girl tells you she wants to see you, she doesn't know, maybe a week from today, then she's not interested. Mm, I don't think she's interested. Mm. She was very excited, but wait, what happened? Hey, Hamburger, what's up?
Oh my, I had kind of a bit of a night last night.
What happened?
Somebody that I caught catfishing other people was catfishing this guy, and they found out about it through my YouTube videos. So they reached out to me for like clarification and like to ask me what my experience was with them, and I was like, yeah, they're terrible, and it was just really like it was good. It was kind of surreal, but I was like, basically the only thing that kept this kid from wasting more time with this person who was taking advantage of him. So I feel valid in what I do.
You feel
Like I feel like I've been vindicated in a sense.
that's good.
I feel a little bit um like worried I'm gonna be attacked soon,
Well,
but I feel mostly good.
that's good. Yeah, I mean, it's okay to be attacked.
Um, I don't like the shit they're saying because they're trying to say I'm like a pedophile and like I go with kids with my ex, but they don't have anything to hold up the claim because I didn't do that.
It doesn't matter. When people go, like I have people, like just yet last night, somebody, people come in and scribble while I'm teaching, while I'm doing physics. They come in and they scribble on my live stream, which is fine. Usually
Oh,
they draw penises, which is fine. But then
well,
yesterday they also wrote stuff about schmidophilia, that, and then I had to ban them in real time. And that's just I think people are, I don't know, people are bored, people don't have a life, they think.
people are also just trying to shift the blame onto somebody else because they're actually the ones who are doing it.
Oh,
And
they're
that's kind of more what I'm getting in my experience because I'm just straight up accusing people of what they're doing. You know what I mean? Like I'm not gonna watch someone like take advantage of another person without just saying so. Which I'm glad to do it because when this was happening to me and I was being taken advantage of by my ex and he was grooming kids, instead of people telling me and showing me what was actually going on, they just made fun of me, mocked my appearance and my age, and said stuff about my weight. Like, it had nothing to do with what was going on. And then I remained in a relationship with someone for 2 years who was abusive to me and fully taking advantage of me. The only time I was able to block him, because he used to use the police to try to control me, the only time I was able to block him was when I found out about the children and I had screenshots of it and videos of it. And I said, don't ever talk to me again. I found proof that you're a pedophile. And then he couldn't reach out to me or abuse me anymore because if he did and if he sent cops to my house again, I would just say, I broke up with this guy. I found out he was talking to kids online. Here's the video proof of it. So he was fucked, and that was the only way I ever got rid of him.
amazing.
And
Yeah,
it took too long to get to that point because people would rather make fun of me than help.
Well,
And I'm not going to be part of that bystander effect. I think that's disgusting. And this is all coming from the vegan community where they supposedly care so much about life. And they want to care about preserving life. Oh yeah, but quality of life doesn't matter. And, you know, making someone's life a living hell, that's okay.
hmm yeah. I mean, you know that in the 80s, there was a wave of kindergarten teachers that were accused of running pedo rings. Did you hear about that?
That's not something I know about. No, I don't. I haven't lived through the 80s and I never heard about it.
Let me get you a link. It's unbelievable. It's like so many lives were ruined by that, and nobody cares. No one is accountable for all these lives destroyed by this nonsense. So,
Right. Yeah.
Kinder,
People like to attack teachers, like, and you know, people who have to work with the public, like doctors or um, like nurses. Like, I was attacked for people said I was like abusing my grandmother, and they were like, "We're gonna call like for elder abuse," and just the straight up stress of that. I don't know if anyone ever called or not, but the stress of that like drove me completely fucking insane. It's like having children at that point too, but also be a liability. Just give people something to harass you over. But I've seen horrible displays of child abuse on Discord, like people like letting their children listen to these horrible conversations that are for adults while they're like toddling around, and like I've seen people pull their kids on the camera and say like tell this person to go fuck themselves. Like, you know, I've seen people live in complete squalor, drug addiction, while kids are running around in the background. You know, it's just like the world's not fair, and the fucking absurdity of it gets to me a little bit.
one second. Let me.
I also, I yeah,
Mhm.
yeah, go ahead.
No, I want to look for it, and if we keep talking, I'm not gonna find it. So let me look. Kindergarten pedo rings. I think it's in the 80s. Yeah, it's called the Satanic Panic. Never heard of the Satanic
Oh, I
Panic?
knew about Satanic Panic, but I thought that that was just attacking like people who were like alternative or dressed a different way, you know, make music. I thought that mainly was attacking like the media. So there was a Satanic Panic, and that involved kindergarten teachers.
Yeah. Okay. Let me share it.
They thought they were worshiping Satan and hurting the children.
Oh, I can't share it because I'm streaming. Um,
That's okay.
so
I
just
can
play
Google
it.
my own stuff.
So let's play it at the same time. So I'm gonna click it and I'm gonna play it.
Okay.
In what may become one of the biggest child molesting cases ever on record, 7 nursery school teachers were arraigned today on more than 100 counts of child molestation.
The accused include the preschool owner, 76-year-old Virginia McMartin, her daughter, and 2 grandchildren.
Finding out just what happened to the McMartin preschoolers in Manhattan Beach, California, would spark a national media obsession,
a case which has shocked much of Southern California and caused a lot of parents to worry about the safety of their children.
setting off a panic around the country.
In alarming numbers, preschoolers have been exploited.
Could it be your child? The media blitz demonstrated unstinting belief that this had happened.
It was sensational and lurid and seemed to always be expanding.
1,400 children in this community have been ritualistically abused.
But were they? Decades later, while the McMartin case has been largely forgotten, its impact lives on.
The McMartin Preschool in Manhattan Beach, as it looked when we photographed it discreetly just 3 weeks ago.
She said that was such
Local reporter
confidence.
Wayne Satz of KABC in Los Angeles broke the...
What? What did you say?
She said that with such confidence. But they're
Yeah, I'm running.
not just abuse, but ritualistically abused.
I'm running it at 1.5 speed, so I'm ahead of you. But yeah.
Oh, I never do that.
Oh, it's fine. It's fine. You watch it. This is important. I'm showing it on my stream too.
The story.
It started out here in Manhattan Beach looking like an isolated incident. One mother noticed that her young son was having nightmares and difficulty sitting down.
Teachers at this prominent Southern California preschool were accused of sexually molesting their young students.
Authorities now believe that at least 60 young children were victimized, and that the ultimate number could well be much greater.
Fueled by unskeptical press reports, the charges mounted on the evening news.
Those children, some of them as young as 2 years old, were photographed by the suspects.
Skinny porn was the primary purpose for the alleged sexual abuse of children.
Becoming more and more bizarre.
Some children allege that a living creature was sacrificed on the church's altar.
The truth about Satanism is they truly do use blood, and they mix it with urine, and then they also use the real meat, the real flesh. This is what makes Satanism true, and this is what 1,200 molested kids in the city of Manhattan Beach have told the sheriff's department.
Most of the allegations had been made here at Children's Institute International, CII, a child abuse prevention center. At the request of prosecutors, CII social worker Key McFarlane and her team had been videotaping interviews with the preschoolers.
Using puppets to encourage the children to reveal what happened, the therapists were able to unlock the horrible secrets of the McMartin School.
Virginia McMartin, her daughter, 2 grandchildren, and 3 other teachers were ultimately indicted on more than 300 counts of molestation.
2 South Bay preschools.
It wasn't long before accusations of abuse were being reported at 7 other daycare centers in LA County alone.
Investigators were at the Hickory Preschool in Torrance earlier today.
And then fears spread across the country, eventually targeting scores of daycare centers. But the story that initially fed the panic was not all it seemed. In the summer of 1983, a 39-year-old mother called the Manhattan Beach Police Department and accused McMartin teacher Raymond Buckey of molesting her 2.5-year-old son.
In the DA's office, all kinds of doubts developed, particularly about the fact that the mother of the first complaining child was psychotic, but they just kept on going. It was like the Titanic. It was like a roller coaster or a ship that just was out of control and couldn't stop.
The police released Buckey for lack of evidence, but then they sent out this letter to some 200 families, instructing them to question their children about sodomy, oral sex, and fondling.
What happens then is the parents start to talk to their kids, and then they start to talk to each other, and then they start to compare notes, and pretty soon emotionally involved parents are engaging in leading and suggestive questioning of the child.
Kenneth Lanning worked with the FBI's Behavioral Science Unit and consulted on the McMartin investigation.
Once these cases are contaminated, it's almost impossible to know with any degree of certainty what actually happened.
But the therapists at CII believed they knew what had happened. Based on their videotaped interviews, they said that more than 90% of the 400 preschoolers they talked to reported signs of sexual abuse.
Mr. Parrott, can you help Susie show us what happened to her?
The courts immediately sealed CII's interviews with the McMartin children. But the CII therapists shared demonstration videos like this one with the press and discussed their findings on television.
We have heard it 100 times or more from children. The same things, the same games, the same descriptions.
I can't say that I ever saw a videotape where kids said this happened to me. Never of their own account, spontaneously.
The interviews are upsetting to read because essentially what happened is the therapist unintentionally coerced the children into fabricating stories of abuse.
Richard Beck wasn't even born when the McMartin story first broke in 1984. Fascinated by the panic that spread across the country, he has been researching and writing a book on the case for the last 2 years.
You have interviews that will start off with a therapist asking a child whether they'd ever played any naked games. At McMartin, this was a huge topic, was naked games. And the children initially say no. The therapist, though, didn't accept those answers. So then they repeat the question. And then they repeat it again. Eventually, the children realize that their interview is never going to be allowed to end until they start giving the interviewer the kind of answer that she wants to hear.
It was obvious in the interviews that all kinds of techniques were highly suggestible, highly pressuring, and is capable of creating false memories of abuse in children, often permanent memories.
Key McFarlane is no longer with CII. She declined our request for an interview. Dr. Stephen Ambrose has been working with children for more than 25 years and was at CII during the McMartin interviews.
I think our therapists, in many respects, started out being very careful about that back then, but as they became more persuaded that something had happened, there probably were some leading questions.
Dr. Ambrose says the McMartin case came about just as a new understanding of child sexual abuse was emerging.
It happened right at a time in the sort of the history of the field when we were just beginning to come to terms with the fact that child sexual abuse was a real phenomenon.
Wake up, America. This is your wake-up call.
People don't want to believe that young children have been molested. They much prefer to believe that it's not true.
We believe the children because once upon a time, we were the children, and nobody believed us.
But that belief was sorely tested as investigators searched for physical evidence to back up what the children were saying.
No pornography that could be linked to the abuse that the children were describing has ever been found.
There should have been little animal carcasses. There should have been bodily fluids all over the preschool. They didn't have any of that.
And what about those early claims of satanic abuse?
There certainly have been mentally ill people who have gone out and killed people, quote, in the name of Satan. But There's never been any proof that there was any kind of satanic ritual abuse or satanic cult activity in a daycare center.
When I first got involved in these cases, I'll be very honest with you, I tended to believe that this was going on. But eventually, the number of cases just kept growing and growing and growing. And at some point, I came to the realization, this many people can't be doing this to this many victims for this long and not leaving any corroborative evidence behind. It just doesn't work that way.
18 months after the McMartin investigation began, the case took a dramatic turn.
What we're left with at this point is that for 5 of the 7 defendants in the McMartin case, the evidence is so slim that it does not go beyond the mere accusation.
So in April of 1987, nearly 4 years after the first accusation was made, the case against the 2 remaining McMartin defendants, Raymond Buckey and his mother Peggy McMartin Buckey, finally went to trial. In court, medical evidence supporting the prosecution's case couldn't be established with...
Yeah, no one knows about this. This is the world in which...
That's exactly what my ex did to me, was create like false memories by asking me things over and over again while I was in trance. That's sick. That's sickening.
Yeah. This is the world in which we live. And no one... And this woman, she denied their request for an interview, the child psychiatrist, whatever. That she basically...
This makes me want to like cry.
Yeah. This is terrible, and these people, their lives, so many lives were destroyed, and no one is paying the price for this. No one. And this happens all the time today. Like what Alex did to me. You know, Alex from Playing with Fire. He just accused me nilly-willy because I was defending someone from him, from the mob. So Alex decided to come after me nilly-willy. Just nilly-willy came after me, and the whole mob turned against me. And that's it. And there's videos. He made multiple videos about me. And that's it. And everyone who looks me up finds his videos because he's a big channel and I'm tiny. And then everyone thinks, the internet says. Anyway, and that's the world in which we live. Anyway, so let's. I'm going to stop watching the video now. Let me see how long
Yeah, I got the point. Like, holy hell.
Yeah, it's unbelievable.
Yeah, I hate that happens to children. I hear about that happening to children at public school a lot too. Like, just this line of questioning continuously until they give the right answer.
It's not just the children who were abused. It's the adults who were abused. Everyone was abused except for the child psychiatrist. She thought she is Jesus incarnate.
She was probably... was this like someone that maybe was included? Like, you know how the Unabomber was included in like MK Ultra, and like we found out after the fact, like was she maybe one of these people the CIA used just to like manipulate others?
I don't know anything about him. I didn't look into that. But this,
I'm gonna look into that. That seems very MK Ultra to me.
I'm fascinated by mob events. This is a mob event.
Yeah, but I saw that as a mass hysteria. You showed it to me, but that's horrifying consequences.
But this is why humanity is doomed. We are simply it's hopeless. And now because we have the internet, so the next such mob event, it's going to be planetary. And that's basically what global warming is. That's basically COVID. These are just mass hysteria events that when you look at the science, there's nothing there. And it's very difficult to explain to people that there's just nothing there. And, there's nothing I can do.
I wouldn't be willing to believe that if it wasn't for incidents like this.
Exactly.
Like, you know what I mean? Where it's like, when you say that initially, it's like, what the hell are you talking about? People are getting sick, but at the same time, yeah, like, what the hell?
Yeah, and the same thing now I'm finding is quantum physics. Quantum physics has been elevated to this weirdness. The universe is weird, and the universe is this, and the universe is that, and it's like when I'm starting to study quantum physics, I see where the problems come from. The universe is extremely mechanical. There's no issues with the universe, but people want the universe to be weird, and quantum physics is another mob event, and physics is susceptible like any other social event. Physics too is susceptible to these mob events. So, what?
Sorry, I just blew my nose. But
Oh. Anyway, so right now I'm going through my own discovery of quantum physics, and I'm trying to make sense out of it. And slowly, I'm beginning to make sense out of it. But yeah, it's a complete nightmare. I mean, humanity is a complete nightmare, and the AI is not going to be able to help us because the AI is just as susceptible to these mob events as the rest of us. The AI is just imitating us, so it's going to end up just like us. Anyway, I'm gonna get back to finishing up my stream, unless you can watch it. Why don't you watch it till the end, and then we can discuss it if you want to discuss it.
yeah, sure, bud.
Okay, so let me know when you're done, and we'll continue. So I'm gonna go back to my streaming my thingy. All right. So show. All right, let's continue.
Are entangled. Entanglement is a correlation, like the correlation between the.
You think nothing of what she's saying. Entanglement is a correlation. She's the only one who says entanglement is a correlation. The others literally say entanglement is not correlation.
Numbers in the envelopes, and like the correlation between the envelopes, it can stretch over a distance. The difference between the two cases is that if you think that quantum mechanics describes all there is, then before you make a measurement, the particles really are in both states at once, and then the update is really physically non-local. The idea that this update is
let's listen to this again.
Between the two cases, it can stretch over a distance. The difference between the two cases is.
Let me just make sure the audio is fine.
It can stretch over a distance. The difference between the two cases is.
Let me just make sure the audio is fine. The audio is fine.
That if you think that quantum mechanics describes all there is, then before you make a measurement, the particles really are in both states at once. And then the update is really.
I mean, if you really believe that, then you don't believe in science. You're anti-scientific because that's not a mechanical explanation of the universe. You cannot have. What are we? I don't even know what we're talking about. What is she talking about?
Describes all there is. Then
the entangled particles. Yeah. So they're both spinning in both directions simultaneously. That doesn't make any sense. And that's what everyone explained. Everyone explained, they're spinning simultaneously up and down, simultaneously in every direction, everything is simultaneous until we measure one, and then the other one collapses, and then that's what they all teach. This nonsense.
Before you make a measurement.
Wait. Let me check. I have an Instagram notification. Who is that? Oh, that's a guy. I know this guy. I need to block him. I don't want anyone from my real life. I need to remove everyone from my real life. Restrict, block. Can I remove? Well, am I following him? Yeah, I'm following him. So unfollow. I don't want to follow him, but I also don't want him to follow me. So I block him. Or restrict. What do I do? Restrict, block, report. I think I'm gonna block. Block. They won't be able to message you. I don't want anyone from my real life to see my actual profile. This will also block any other accounts they may have. They won't be able to message you. or find your profile. That's good. Block. That's perfect. Yeah, I'm becoming a little bit hungry. Just a little bit hungry. Wow, some women are really beautiful. Oh my God, this chick is so beautiful. Beautiful, beautiful, absolutely beautiful. Okay, let us continue.
And the particles really are in both states at once.
Yeah. And infinite states. It's not just both states. It's not just up and down. So you want to tell me an electron is in every has what do you call it? Angular momentum in every direction simultaneously, because it can't be just any one direction or any two directions. It's every direction. So it's spinning in every direction simultaneously. That's what you want me, that's what you expect me to believe? That's a mechanical explanation? I don't know, I cannot imagine such a thing. So I have to stop you right there. And of course, if I just take your word for it, then of course from there it can only go downhill, and you're going to tell me more and more nonsense about the universe.
The update is really physically non-local. The idea that this update is physically real is what Einstein called a spooky action at a distance. He thought that can't be right. Einstein believed that the real...
That's the problem with Einstein. He didn't have a good philosophy of science. It has nothing to do with what you think. It has nothing to do with the universe. It has to do with your assumptions about the universe. My assumption is that the universe must be mechanical. Otherwise, I cannot understand it. So what's the point? What's the point of science if I cannot understand the universe? I don't know the point. What is the point? If I cannot understand the universe, then what's the point of trying to understand it? If it's given, I might not be able to understand the universe. If I might not, then any time that I don't understand, it might be just that I cannot understand it. And I'm wasting my time trying to understand it. So I think I cannot, as far as I understand, it's a dead end. I need to assume the universe is completely mechanical. It's completely understandable. Completely understandable. However, we can only peel one level at a time. So right now, to me, it's clear there is an ether, and there is a mechanical ether. And it has particles that have forces between them. It could be really particles. The problem is these particles seem to annihilate when they impact massive objects. So that can't be right. So they can't be made out of actual matter. So they too are not weird, but it has to be something that can dissipate without leaving a trace. Because right now there's ether flowing into me and it's not leaving a trace. The only trace is my inertia. That's a trace. So you would say, okay, that's the trace. What do you want more? The most powerful force in the known universe, gravity, is caused by this annihilation. But where does it go? Where does it go? We don't see the impact. We don't see a wave coming out of it. There's no waves emanating. There's nothing. I mean, maybe there are waves that as soon as, so when the ether flows into me, maybe there is a wave, because every ether particle needs to collapse, needs to annihilate. And that annihilation I cannot imagine. I just cannot imagine. But anyway, that's where I'm at right now. The universe is completely mechanical. Every particle in the universe is a wave waving in this mechanical ether. It's really very simple. Just all different types of waves. And you can create very nice waves using Fourier transforms, Fourier series. You can create any wave you want. Any wave you want, you can create. And for some reason, some waves are, there's standard waves. So there's photons and there's electrons and there's quarks. There are the standard ones. So there's standard waves that always show up. The question is, why are photons incomplete? Why is every particle an incomplete wave? How do they manage to always be these incomplete waves? Why? Why don't they become complete waves, complete spherical waves? Like I don't know the rules, but that's the intuition. Okay, so that's the next level. That's the next layer that we need to research.
Process must be local, and that the update just revealed something you didn't previously know. That something you reveal in the measurement is usually called the hidden variable. It could be, for example, the value of the spin that the particle really had before you did the measurement and found out what it is.
No, that's not the hidden. The hidden variable is something we've never found. It's something that causes the spin. She doesn't understand hidden variables?
This must be local, and that the update just revealed something you didn't previously know.
The update doesn't reveal why it was spinning the way it was spinning. We never find the hidden variables.
Something you reveal in the measurement is usually called the hidden variable.
No, that's not the hidden variable. We never have access to the hidden variables. That's why they're called hidden variables. We don't know what those variables are. The spin is not the variable that is hidden. And we're trying to predict the spin, but since we don't have access to the hidden variables that are causing the spin, that's why the spin it looks like it's probabilistic.
It could be, for example, the value of the spin that the particle...
No, it's not the hidden variable. That's not the variable. That's the outcome that is controlled by the variable.
Really had before you did the measurement and...
No, you're trying to predict and you don't have access to the value of the hidden variables. You don't even know what those variables are. That's why you cannot give a prediction.
Found out what it is. Bohr held against that. He said there are...
Bohr was nuts. Bohr was probably mentally unstable. He said we should give up on momentum, on conservation of momentum.
Are no hidden variables, and
there's a quote I saw. He said it. As far as I know, it's true.
No underlying information that you can...
He looks like a normal guy, but he was not normal. What he said was completely abnormal, and everyone today is his student, except for her.
Reveal. The wave function is all there is, and the collapse is really non-local.
Oh my God, the collapse is really non-local. So physically something happens. Physically, the wave collapses, and the particle disappears from everywhere else in the universe and appears only in one spot, instantaneously, violating every law of physics.
Bohr seems to have liked quantum mechanics because he thought that its indeterminism makes place for free will, though that's rather...
So he was a religionist. What was his relation with religion? Bohr and religion. Let's see, was he a religionist? Nicola Bohr. Who is Nicola? Niels. Let's look it up. Let's look into his dark automatic. Why don't you remember? Jesus. Okay, so I want to know, what is your point of view about God? Only one. Okay, not too much. Religion. 5. A statement about religion in the loose notes on Kierkegaard may throw light on the notion of wildness that appears in many of Bohr's letters. I, who do not feel in any way united with and even less bound to a God, and therefore am also much poorer than Kierkegaard, would say that the good is the overall lofty goal. It's only, I don't know what he's talking about. Use parables as stories, tolerance, dependence, I don't know. Religion and science. Science and religion dialogue. That's the last one. Spiritual choice. Freedom, no. Choice. Indeterministic. No. Einstein preferred the determinism. Okay. Understanding the true meaning of complementary would Bohr believed require closer investigation. What? This makes no sense. February 27, Heisenberg developed, this is about Niels Bohr, developed the first version of the uncertainty principle, presenting it using a thought experiment where an electron was observed through a gamma ray microscope. Bohr was dissatisfied with Heisenberg's argument since it required only that a measurement disturb properties that already existed, rather than the more radical idea that the electron's properties could be discussed at all apart from a context they were measured in. In a paper presented at the Volta conference at Como on September 27, Bohr emphasized that Heisenberg's uncertainty relations could be derived from classical considerations about the resolving power of optical instruments. Understanding the true meaning of complementarity would, Bohr believed, require close investigation. Einstein preferred the determinism of classical physics over the probabilistic new quantum physics, to which he himself had contributed. Philosophical issues that arose from the novel aspects of quantum mechanics became widely celebrated subjects of discussion. Einstein and Bohr had good-natured arguments. I don't know. That's the only determinism. But I'm looking, what kind of psychology? Did he have mental issues? Let's look for mental issues. Instrumental, experimental, there's no mental. Mentally disabled. The sister of Niels Erik Bohr resigned his membership Church of Denmark. And he and Margaret were married in a civil ceremony at the town hall. So he was a church member. He's like from the Netherlands. Years later, his brother Harold similarly left the church before getting married. Bohr and Margaret had 6 sons. The oldest, Christian, died in a boating accident in 1935, and another, Harold, was severely mentally disabled. He was placed in an institution away from his family's home at the age of 4 and died from childhood meningitis 6 years later. Age Bohr became a successful physicist in 1975. Was awarded a Nobel Prize in Physics like his father, a son of Age. Wilhelm A. Bohr is a scientist affiliated with the University of Copenhagen. So they live in the Netherlands, I guess, and the National Institute on Aging in the U.S. So he's not a physicist. Hans became a physician, Eric a chemical engineer, Ernest a lawyer. Like his uncle Harold, Ernest Bohr became an Olympic athlete playing field hockey so he's a giant for Denmark. Oh, Denmark. At the end of 1948 Summer Olympics in London. I'm looking for something unstable in his mental capacity. That's it. There's nothing. But he left the church. Let's look at the church. What's going on with the church? Nothing? How? We just saw the church. Church. Okay. Maybe I misspelled it. Church. Church. So there's 5 churches. Churchill. When Churchill. That's it. So it's mostly Churchill. So what do you mean he resigned his membership? What do you mean his membership of the Church of Denmark? What is this church? Evangelical Lutheran Church in Denmark. Why did he resign? Called established state supported. The supreme secular authority of the church is composed of the reigning monarch in Denmark, whatever. I don't know. Okay. Bizarre. Oh, my eyes are burning. Oh, we need to, when we go back, we'll read the comments from the previous stream.
Questionable. We just talked about that a few weeks ago. Einstein did not use the phrase spooky action at a distance to refer to entanglement. To begin with, the example in which he coined the phrase didn't use entangled particles. I went through the history in the previous video. But more importantly, entanglement has no action. It's just a correlation that stretches over a distance, like the correlation between the envelopes. When I read the headlines about
That's incredible that she says that, because the Stern-Gerlach experiment, there's no entanglement in Stern-Gerlach. Stern-Gerlach would be interesting to think about. Oh, I have a phone call. We might have to end. Let me check if it's urgent. Where is it? There it is. All right. Okay, we're gonna have to finish because I need to talk to someone to really calm them down. That's my job. All right, so yeah, we're gonna have to finish. I really want to hear her saying those words. Maybe she'll say it now. Hold on.
About last year's Nobel Prize, I got the impression that some science writers believe entangled particles are somehow mysteriously linked to each other. They seem to think that if you do something to one particle in an entangled pair, then that'll immediately affect the other one. But this isn't so. It's only when you measure one particle, then you have to update the wave function of both. So long as you don't measure them, doing something to one particle won't affect the other one. You could, for example, flip the spin of one of the particles in an entangled pair so that one becomes -1 and the other way around. You can do that without measuring the spin, like you can do this in reality, in the laboratory, not just with mathematics. If you flip the spin of one particle without measuring it, this will not do anything to the particle it's entangled with. It's not as weird as they made you believe.
If that's true, then entanglement, exactly. It's not as weird as they made you believe it is.
It is it? Okay, so
What do you mean, is it? Why are you asking? You know what's going on in the lab.
entanglement is just a correlation over long distances. But does it at least allow us to send signals faster than light? Unfortunately not. It doesn't work because you can't force the outcome of your measurement on one of the entangled particles to be a particular value. It'll just be randomly distributed according to the probability given by the wave function. This means that on the other end, they won't know whether you have made a measurement any more than Bob knows whether Alice has opened her envelope.
Wow, this is absolutely remarkable. I mean, she's going against what everyone is teaching about entanglement.
If quantum mechanics is correct, then no information can be sent faster than light.
Because the way I understood entanglement, you could easily peer into a black hole, and that is what Lenny Susskind is teaching. She needs to talk to these people. I think this is why she's friends with Eric Weinstein. Unfortunately, he has his issues. Everyone has their issues. I heard Eric speaking against Lenny Susskind. He hates Lenny Susskind. I mean, he really wants to harm him physically. That's the way it sounds. He really dislikes him.
Mathematically prove that this is
I mean, they destroyed Eric. From what it sounds, he really regrets that he left academia.
The case, not just for this experiment, but for any possible experiment. It's called the no signaling theorem. But because of this randomness of quantum mechanics, it's also rather unclear in which sense the collapse is even non-local. If making the measurement on one of the pair of entangled particles doesn't change the measurement outcome on the other one, then what is non-local in the first place? Enter John Bell. Bell tried to find a way to pin down what it means that quantum mechanics is non-local. Please put the space-time diagram back into your head because we need it again. We've seen earlier that without faster-than-light travel, everything that an event might be influenced by has to be in the past light cone. But if the theory is also local, then you don't need the entire inside of the light cone. This is because if you know what happens at one moment in time, you can calculate what happens later. If the theory is deterministic, you can calculate it exactly. If it's not deterministic, probabilistically. This means all you need is the information at one particular moment in time for anyone's notion of time. In one dimension, that moment is a line going through the inside of the past light cone. In 3 dimensions, it's what's called a space-like hypersurface, just so you don't go away disappointed about the lack of incomprehensible terminology. The point is that the information at one moment in the past light cone of the event is all you need.
I'm alive. I'm just at this point. She's saying I don't know where she's going. It's really remarkably simple. I don't know where she's taking this discussion. I don't see how this is relevant to Bell. We'll see.
to calculate what happens at the event.
So all you need is access to any point in the cone. Like you need the hypersurface of the history of the cone. Any such surface predicts the entire future cone.
If the theory is local. If the theory isn't local, then that doesn't work because information could
Yeah, that's correct. That's good.
jump into your light cone
Okay, so that's where Bell comes in. Okay.
later. Bell's insight was now that you can use this to decide whether the theory is local, and it works even if the theory has a random element. Suppose you have all available information on this slice here, and you use that to make your best prediction for what happened here. Then the theory is local. If
So you
it
take the
connected
high.
here, it doesn't tell you anything new
Oh my god. So you take the hypersurface in the history of A, and from that you can predict A. Okay.
about what happened at A. Bell called this property local causality. If, on the other hand, the theory is not locally causal, then information can jump into the light cone after your slice, and that can tell you something about what happens at that event. Quantum mechanics is not locally causal. Think back of the earlier example with the entangled particles. Let's say they are created here. One
Wait. Quantum mechanics is not locally causal? What? What?
called this property local causality. If, on the other hand, the theory is not locally causal, then information can jump into the light cone after your slice, and that can tell you something about what happens at that event. Quantum mechanics is not locally causal. Think back of the earlier example with the entangled particles. Let's say they are created here. One goes left, one goes right. In the space-time diagram, this means they go diagonally, no less than a 45-degree angle. You make two measurements here and here, let's call them A and B. We want to know what happens at measurement A. All the information you could have about it is down here in the wave function. This wave function, as we've seen earlier, does not allow you to predict the measurement outcome at A, just the probability of a measurement outcome. It's either spin -1 or +1 with 50% probability each. Here's the thing. If you make a measurement over here at B and you find it's +1, then you know the spin at A is -1.
Okay, so you created the entangled particles here. You measured this one to be +1. That's the envelope. It should be spin, whatever. Okay, spin +1. So this must be spin -1. Yeah.
So what happens at B does add information to the inside of the past light cone, and quantum mechanics is not locally causal.
Okay, so she's saying once you know this, then you immediately, instantaneously know something about A, which is a violation of locality. But this is information locality. It doesn't mean anything. This is boring. This is the boring violation of locality.
Also, the important thing is now that local causality is a property of a model. In this case, a property of quantum mechanics. The relevant question is whether it's also a property of reality.
No, it cannot be. That's a violation of science. I cannot understand what that means.
If quantum mechanics was all there is, then that'd be the case. The wave function would be how the world really works, and it would have a spooky
No, exactly. It would have a spooky action at a distance.
action at a distance. But if quantum mechanics was not all there is, then the wave function down here was not the entire information. There'd be a hidden variable there from which the outcome followed. And if you had the entire information, then adding the measurement outcome from B would not provide any further information. Quantum mechanics would still not be locally causal, but reality would be. So which one's right? That's what Jean Bell was trying to figure out. Wow, you're still with me. That's lovely. I really appreciate the company. Let's look again at that semi-transparent plate because it can teach us something very important. We'll now try to build a simple hidden variables model that explains what happens at that semi-transparent plate, also called a beam splitter. We want to do this with hidden variables, and we want to do it locally, so no action at a distance. The hidden variables are usually called lambda. So we'll say if lambda is 1, then the photon goes that way. If lambda is 3, then it goes the other way. Why
Okay,
3,
so
not 2?
why am I not able to stop it with... Anyway, so lambda is the hidden variable. There is a hidden variable called lambda that's going to actually cause this guy to go left or to go right. If it's 1, it goes there. If it's 3, it goes there. And I need to finish and take a phone call.
I know what's coming next, and you don't. Now we put 2 mirrors here and here so that the photons don't run off our screen, and another 2 semi-transparent plates there. Okay, so now we have 4 different paths, each with 25% probability. We'll give those the numbers 1, 2, 3, 4. And now we'll combine these 2 paths by directing both towards the same beam splitter. If our hidden variable explanation was correct, then we should get half of the photons here in detector A and half here in detector B. But this isn't what happens. Indeed, you have probably noticed that this setup is what's called a Mach-Zehnder interferometer.
I never heard of a Mach-Zehnder interferometer, and I don't see the point of it. What do you mean this is not what happens?
If the paths are the same length, then the photon will always go to detector B.
Why? I don't understand.
You can measure it and all. It's definitely real.
What? This doesn't make any sense.
The interference in these detectors is exquisitely sensitive to the length of the paths, which is why one can use this type of interferometer to measure tiny...
How is the length of the path relevant? I don't understand. What's going on? It looks like a square to me, so there is no difference. So it chooses here what to do. If it goes this way, and then here it needs to choose again. And it could either choose left or right. Why would it always choose to go straight? And the same for this one. If it gets to this point, why should it always make a right turn? Why not sometimes go straight? I don't get it.
Deformations. This is how a gravitational wave interferometer works. But
a gravitational wave interferometer works like this? Okay, how is this relevant?
how does it work? Well, in quantum mechanics, the photon is described by a wave function, and waves can interfere with themselves, either
when they go through a two slit, but not without a two slit.
constructively or destructively. In quantum mechanics, the photon goes over both paths, and on this output, the wave interferes destructively with itself, so no signal, and all photons go the other way. But the price you have to pay for this is that if you measure which path the photon went, you need the non-local collapse. How can we use hidden variables to get this done?
Well, I don't know what she's talking about. I never heard of this experiment. I never knew this. It goes through both. I never knew it goes through both. I mean, if it can go through both, it could do that. It could go through two slits. As a wave, it's allowed to spread as long as it doesn't spread into two separate waves. It has a range. I don't know the limitations. I don't know what it has. So, okay, so as a wave, it went in both directions. I don't know the limits of this behavior of the wave. Anyway, we're going to stop here. I need to eat and I need to make a phone call. This is very interesting. Okay. Thank you so much for listening. See you next time. Bye.